All right, so this particular problem asks us to complete the table of ordered pairs at the right and then to plot those ordered pair solutions. Well, I'm simply going to use what I know and solve for what I don't know. And so because there are three things here, that's 3 times I have to work the same problem, which is fine. In the first one, it tells me what x is and asks me to solve for y. So it tells me that y is equal to 1 over 7 times 0 plus 7. Well, anything times 0 is 0, and 0 plus 7. So that's going to get me to y is equal to 7. So if x is 0, y is 7. Then I've got to find what if x were 21. So then I'm going to use the same equation. And I'm going to do, but this time I'm going to do y is equal to 1 over 7 times 21, because that's what they told me x was. And that's going to be plus 7. So y is equal, if you do 1 over 7 times 21, you're going to get 3. And then 3 plus 7 is 10. So y would be equal to 10. So if x is 21, y is 10. Then, on the last one, I'm going to use the same equation, only this time they said, hey, they didn't give me x, they gave me y. And they said, hey, y is 0. So 0 is equal to 1 over 7x plus 7. So this time I have to solve for x. So I'm going to subtract 7 from both sides. I'm going to get negative 7 is equal to 1 over 7x. Now, I can't divide by a fraction. Like, I can't divide both sides by negative, or divide both sides by 1 over 7, because A, that's dumb, and B, we don't do it. But, so instead, I have to multiply by my reciprocal. That way it doesn't look silly when I write, divide by 1 over 7. So instead of multiplying by, or dividing by a fraction, we multiply by the reciprocal. Remember that a reciprocal of something is when we flip it upside down? So 7 over 1. So over here I'm going to multiply by 7 over 1. These are going to cancel out. 7 over 1 times negative 7 is a negative 49 equals x. So if y is 0, then x is negative 49. So that's kind of how that's going to work out for us. Now, the second part of that tells us to plot the ordered pair solutions. So keep in mind ordered pairs are written x comma y. So this first one would be 0, 7, followed by 21, 10, followed by negative 49, 0. Now, luckily they didn't say, hey, here's a whole graph, make it your own, and we had to use these huge numbers. Instead, they gave us numbers to look at. So I'm looking for 0, 7. So 0, 7. All right, 0, 7. Well, this one doesn't have a 0, 7 on it, and this one doesn't have a 0, 7 on it. So I automatically know that those are out. Okay? Then my next one is 0, well, the next one's 21, 10. So 21 would be this way, positive 21. Well, this one goes back to the negative. All right? And then plus this one right here, is that going to be, that might be close to 21. Maybe. So we'll hold off on that. And this one looks like, well, there's 26. All right, well, that's a maybe. All right, maybe. Then, but probably I would say that's going to be a substantial amount away from 26, right? So, and then the last one is negative 49, 0. All right, negative 49, 0. Okay, anyway, sorry. These are going by 2, so 2, 4, 6, 8. This one's going by 2s, 2, 4, 6, 8. Okay, I was just double checking. All right, and then, so negative 49, 0. So negative 49, 0. This would be negative. This would be negative. The primary difference between A and B is this point right here. Okay? And we want to make sure we get the one that's closest to 21. So I'm going to say if these are all 3, then, and they're broken down in intervals of 3, then I'm going to take 26, because again, I'm kind of a dork like this. I'm going to take 26, divide it by 3, and know that each one of these is worth 8. So 8, and then 16, really 9, 18, 21, or 27. So I would say that this one is going to be my answer because that is closer to, this point here is closer to 21 and 10. Oh, that's exact, 2, 4, 6, 8, 10. Yeah, this point is on 10 and this point is on 2, 4, 6, 8, 10, 11. So this point is off the mark. So this one would be my answer of 21, 10. So there we go.